Good day everyone. Our today's lesson is a general introduction about statics, and it will be a part of set of lessons I will upload on continuous basis to cover the most we can about this important topic with some exciting examples that I wish you will like. Let's start with the definition of mechanics. Mechanics is a branch of the physical sciences that is concerned with the state of rest or motion of bodies that are subjected to the action of forces. Mechanics could be divided into three main categories: rigid body mechanics, deformable body mechanics, and fluid mechanics. We are going to deal with rigid body mechanics in our lessons, which could be divided into statics and dynamics. Statics deals with the equilibrium of bodies, that is, those that are either at rest or move with a constant velocity. While dynamics is concerned with the accelerated motion of bodies. As I said earlier, we will deal only with the statics part of rigid bodies in our lessons. First of all, let's agree on some definitions. Particle. A particle has a mass, but a size that can be neglected. Example, this ring here is subjected to three different forces, all these forces pass through its center. So it can be considered as a particle. Rigid body can be considered as a combination of a large number of particles in which all the particles remain at a fixed distance from one another, both before and after applying a load. Steel as an example is a rigid body. Newton's three laws of motions. Newton's laws of motion are three physical laws that, together, laid the foundation for classical mechanics. Let's start with the first law. It states that an object originally at rest, or moving in a straight line with constant velocity, tends to remain in this state, provided the object is not subjected to an unbalanced force. An aircraft in flight is a particularly good example of the first law of motion. There are four major forces acting on an aircraft: lift, weight, thrust, and drag. If we consider the motion of an aircraft at a constant altitude, we can neglect the lift and weight. A cruising aircraft flies at a constant airspeed, and the thrust exactly balances the drag of the aircraft. This is the first part cited in Newton's first law: there is no net force on the airplane, and it travels at a constant velocity in a straight line. Newton's second law. It states that a particle acted upon by an unbalanced force, F, experiences an acceleration a that has the same direction as the force and a magnitude that is directly proportional to the force. F equals m multiplies by a, where m is the mass of the object. Derivation of Newton's second law formula. Let us assume that we have an airplane at a point 0, defined by its location x0 and time t0. The airplane has a mass m0 and travels at velocity v0. The airplane is subjected to an external force F and moves to a point 1, which is described by a new location x1 and time t1. The mass and velocity of the airplane change during the flight to values m1 and v1. Newton's second law can help us determine the new values of v1 and m1 if we know how big the force F is. Let us just take the difference between the conditions at point 1 and the conditions at point 0. F equals m1 by v1 minus m0 by v0 divided by t1 minus t0. Let us assume that the mass stays a constant value equal to m. This assumption is pretty good for an airplane. The only change in mass would be for the fuel burned between point 1 and point 0. The weight of the fuel is probably small relative to the weight of the rest of the airplane, especially if we only look at small changes in time. So, for a constant mass m, Newton's second law looks like F equals m by v1 minus v0 divided by t1 minus t0. The change in velocity divided by the change in time is the definition of the acceleration a. The second law then reduces to the more familiar product of a mass and an acceleration. F equals m by a. Example on Newton's second law. Consider this car that starts from rest and accelerates to reach a specific speed at specific time t. Newton's third law. It states that, for every action there is an equal and opposite reaction. The statement means that in every interaction, there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object. For aircraft, the principle of action and reaction is very important. It helps to explain the generation of lift from an airfoil. In this problem, the air is deflected downward by the action of the airfoil, and in reaction the wing is pushed upward. Newton's law of universal gravitation. Every particle attracts every other particle in the universe with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. In the case of a particle located at or near the surface of the Earth, the only gravitational force having any sizable magnitude is that between the Earth and the particle. This force, termed the weight. So, if m1 is the mass of the particle and m2 is the mass of Earth, r is the distance between the particle and the center of Earth, and it could be assumed the radius of Earth if the particle is near to the Earth because the distance from particle to ground level is neglected compared to Earth radius. So, the gravitational constant, the Earth mass and the Earth radius are all constant numbers that are equal to g, and from here we get weight W equals mass multiplied by gravity.